Asthma is a heterogeneous airway disease affecting approximately 334 million people worldwide. It's defined by symptoms such as shortness of breath, cough, wheezing, and chest tightness. Asthma can be triggered by various environmental factors, including irritants, allergens, viruses, and bacteria. These triggers induce a cascade of effects, resulting in inflammation and reversible airway obstruction. When these triggers hit the epithelium of the lungs, the epithelial cells are stimulated to produce various cytokines, inducing an inflammatory cascade. These epithelial cytokines working upstream in the cascade include TSLP, short for thymic stromal lymphopoietin. TSLP mediates its effects on target cells by binding to a receptor on dendritic cells. This upstream interaction plays an important role in the initiation and perpetuation of multiple downstream inflammatory pathways. This binding of TSLP to its receptor on dendritic cells stimulates the differentiation of naive T cells into type 2 helper cells. TSLP also activates type 2 innate lymphoid cells and other inflammatory cells, including mast cells, basophils, and macrophages. The activation of these multiple cell types by TSLP results in production of the type 2 cytokines IL-4, IL-5, and IL-13. IL-5 is a cytokine involved in the recruitment, maturation, and survival of eosinophils, which can damage the bronchial epithelium and may cause bronchoconstriction. IL-4 promotes B-cell production of IgE. Allergen binding of IgE on mast cells results in degranulation and release of multiple inflammatory mediators. IL-13 also increases the airway smooth muscle response and is involved in mucus hypersecretion via goblet cell hyperplasia. TSLP is thought to be a driver not only of type 2 inflammation, but also non-type 2, as it can initiate the release of non-type 2 cytokines such as IL-17, which increases neutrophil recruitment. The inflammatory response to these downstream cytokines and inflammatory cells may lead to airway hyperresponsiveness. TSLP expression is increased in patients with airflow obstruction. Due to its upstream position in the inflammatory response and its ability to activate multiple cell types, TSLP drives the cardinal features and symptoms of asthma. As the understanding of TSLP and its upstream function as a key mediator in the inflammatory cascade evolves, there is reason to consider its role across a broad asthma population.